would you introduce tonight's speaker for our program on RFI?
Yes, my pleasure. Tonight we have a special guest. It's Mike Martin, K3RFI. Now, and the subject is RFI indeed. Nobody, I don't think, there isn't anyone who has more experience than Mike. He spent a good part of his life chasing the kinds of problems that plague all of us from time to time. So we're just really delighted to have him here. He's a real professional. He runs RFI Services. His company, he spends a lot of time doing industrial professional work, but he also services a lot of us and helps us out. So Mike's going to educate us, and he's going to do it in two parts. There's going to be sort of an introductory part this evening, part one, and then we already have him booked for February 11th, to do part two for us. So please, Master Mike, educate us on RFI part one.
Okay, let me see if I can get us going here. See if this works. Looks like it's working, huh? Can everybody see me?
Yep.
Yes.
Good
Yes.
shit. Okay, well, thanks for the introduction and thanks for having me tonight. I want to warn you, this is the first time I've sat and talked to a group of people that were in a different place than I was. So we'll see how this works out. I'll get by the butterflies in no time. I started this company, RFI Services, well over 30 years ago. I went to work for a utility in the radio shop, and it didn't take me long to get bored. I got very bored with that, and I heard about this RFI job, and nobody liked it. Everybody hated it because every time they went to a customer's house, which was a ham, they were met with aggravation and impatience. And it didn't take me long to figure out that the reason why things were that way is because they never went and saw the people. They never responded to their complaints. They didn't follow up on promises and resolutions, and they just never, and they never got the opportunity to get good at it because the job changed hands every 2 months. So no one was on the job for more than 2 months at a time. And that company had an average of 32 complaints a month for Powerline RFI. Most of that was from amateur radio operators, and there were quite a few TV interference complaints as well. So what we want to talk about tonight, and we have a lot to cover. You know, one of the worst parts about this job for me and doing something like this is having to remove slides from a presentation to make it work out in time. And that was very difficult for me, but we'll see how things go. You know, I never thought, but my slides are not advancing. Oh, there you go. Tonight is part one. And what we're talking about is not only power line noise, but also power line noise versus power line interference. There's a big difference between these two. Power line noise is what you get about 1 every 2 blocks in the neighborhood. If I survey a neighborhood, I'll find an average of about 1 noise for every 2 blocks in the neighborhood. If I come back the next day and survey it again, I find about the same number, but not the same sources. So one might be gone and a new one start. There might be 2 or 3 new ones today, and the next day there might be only 1. But the average is about 1 noise for every 2 blocks in a neighborhood. And those noises are there. Every one of you that have power line noise that aren't living off the grid and a long way from the grid have these noises, but it isn't interference. And that's very important because anybody can go out and find noise. And most of your utilities are doing just that. They're going out and finding noise, but they're not finding the source of the interference that's bothering you. And that's very important. I want to go through the process and tell you what your power company should be doing. step one and through, and there's a lot of steps in between these, but these are the major steps. And I think most of you really quick will realize that they're missing something. In the investigation process, the first thing they should do is observe the interference as it affects the RFI receiver connected to the station's antenna. Okay, this is very important. Many times the investigator comes out and doesn't connect to your antenna. If he doesn't connect to your antenna, he may see a totally different scenario outside in his truck. There literally can be a noise on the pole in front of your station and it not have any effect on your radio whatsoever. You can have a noise on 80 meters. He can be sitting in his truck and have a noise on 80 meters and it not be the same thing. And the source be on the pole in front of your house. This is extremely common. I see it all the time. So it's very important to connect to the antenna that's receiving the interference and utilize that signal as your first measurement and RFI signature to analyze. So when you connect to that receiver, you're going to analyze the signature of the noise and learn everything you can about that noise just by the pattern that it creates on an oscilloscope. Okay, the next step, they're going to leave your house. They're going to go out and locate the structure containing that source. Okay, that source, that's very important. They're not just going to ride down the road and look for any noise. They want to find the one that's interfering with you. Next, they need to locate the source on the structure that they find containing the source. Now they have to determine what on that structure is going to be causing your interference. Sometimes it can be 2 or 3 different things on a structure, but all you want is the one that's interfering with you, and that's very important. Anything you do that doesn't help lower your S meter is not doing you any good. Even weaker noises in your area, you may eventually see them as the stronger noises get repaired, but fixing those lower level noises have nothing to do with your S meter reading until you get down to the level of that noise. Okay, then the repairs are made by crews to eliminate only the identified source. So all they want to do and all you want them to do is repair the interference source that's affecting your receiver. It does no good to repair noises that aren't affecting you because they're all over the place. They're out there everywhere. Statistically, and this is a very important statistic, if I go out with a utility and I have an untrained lineman working with me and he's going to repair noise on a pole, he typically starts 2 new noises for every noise he's there to repair because he doesn't know how to fix the noise, doesn't know how to find the noise. So if he goes up and just starts repairing any noise on a pole, he stands a chance of starting 2 new noises for every noise that he's trying to fix. And compound that by going up 2 or 3 different poles looking for a noise, and eventually you've got more noise around you than you can ever imagine. And it makes the job even that much more difficult. Not to mention that some of those noises he's starting may, in fact, affect your receiver. Okay. Next, and this is something that is rarely performed by many utilities, they need to return to your station and verify that the RFI signature was eliminated and see if there's any new ones on or any additional. Every investigation is to locate the source that's creating your S meter reading. So if you got 20 over, or in some cases, as we heard from earlier, 30 over, if you got a noise that's 30 over, fixing a noise that's 20 over isn't going to help your signal level at all. It's not a sum of the noises that create your noise level. It's the strongest signal is going to be the predominant one, and that's going to be the one that reflects or affects your S meter reading. Okay, there's a lot of myths, a lot of mistakes that are made in the industry and even outside the industry. In the amateur radio community, there's a lot of things that are done that shouldn't be done. And here's some of the most common. One thing is, it's very common for people to feel that they should start repairing the noise sources that are closest to the complaint. That couldn't be further from the truth. It's very common for me to get hired. I come out and find a noise 2 miles from the ham's home, and I count 30 some noise sources from the one affecting him to their home that has nothing to do with his receiver level, and you cannot see them looking through his antenna. That's extremely common. So imagine if a noise source is 2 miles away, and that's not uncommon at all. A noise source is 2 miles away, and I'm going to start fixing the noise source that's closest to your house. Okay. Imagine that combined with the statistic of a noise for every 2 blocks and a noise, starting 2 new noises for every source that's worked on, or every pole that's worked on. The noises just multiply like rabbits. It's crazy how bad things can get for you. So not doing the right thing can really create more problems than anything can. Okay. Noises detected at a pole are caused by power company equipment. If a noise is radiating from utility company equipment, the utility is required to locate the source and is responsible for correcting the issue. That couldn't be further from the truth. That is not true. Any noise that's created inside your home, your neighbor's home, a nearby business, all those noises radiate through the wiring back out to the pole, utilize the neutral and eventually the primary to radiate the noise. So when you walk up to a pole, you're essentially taking the receive antenna and putting it closer to the transmitting antenna that's transmitting the noise. Therefore, it gets really strong at the pole. In this particular case, the utility is just as much a victim of the noise as you are in your station. This is extremely common. I would say this scenario probably makes up a good 20% of the cases that I'm hired to resolve. Okay, I need to look for power line noise using the same frequency used in my shack. Okay, that's a misconception. Power line noise radiates at all frequencies. At the source, you can detect that noise at all frequencies. The frequency you want to use to locate noise is the frequency your antenna works best at. Whatever antenna you're using, you want to use the frequency that antenna is most resonant at, and resonant may not be the right word, but you get my drift. Wherever that antenna works best at is the frequency you want to use it at. That will give you the greatest sensitivity and allow you to see the noise or hear the noise the furthest away, which cuts down your search dramatically. Keep in mind the importance of utilizing a directional antenna and what happens if you don't use it on the frequency it's designed for, or should I say the frequency it works best at. It becomes less and less directional and isn't nowhere near as effective or efficient as you want it to be. Okay. Yes. Okay. Transformers, cracked insulators, loose tie wires are not likely sources of power line interference. I can't tell you how often I go and I hear the stories about all the insulators that the power company has changed, all the tie wires they've worked on, all the transformers that have been changed. There's only one state that I find transformers to be a big cause of problems, and that's in Florida. And that's it was always believed to be due to the lightning strikes. I haven't found that to be the case. But transformers I hear everywhere in Florida, bad transformers. They're rarely the cause of the interference, but I hear them everywhere and I locate them everywhere. I just don't do anything about them because they're not the cause of the complaint. Cracked insulators are a very rare occurrence. They rarely occur. To crack a porcelain insulator is not an easy thing to do. Now, if they're damaged from a lightning hit, and that happens from time to time, not very commonly, but it does happen, then it's not a crack. It's actually blown up, or it's burnt. The whole top of it is burned out and it's turning white at the top. That's a whole different thing. Loose tie wires. From a common sense standpoint, imagine a tie wire. It's wrapped around about 6 times around the wire. Okay, 3 or 4 times on either side, sometimes more on either side of the insulator. In order for that tie wire to arc, it can't have a good connection anywhere. It has to be totally disconnected from the line to arc to the line. And the line would have to be totally disconnected from the insulator for it to arc to the insulator. So it's very, very rare that that's the case. Now you can grab a tie wire and move it and make it arc intermittently as you're moving it. But as soon as you let go, the noise goes away. I'm not saying it's impossible for it to happen, but it's extremely rare. I do this every other week. At least every other week. I'm in a different state working for a utility. And I honestly can't remember the last tie wire I found. It's probably been 15, 20 years since I found that to be the cause. And they are pointed at a lot. Okay. Somebody arguing again. Okay. Here's another one, and this is debated even with the utilities as well as amateur radio operators. Tightening all the way on the whole, tightening all the hardware on the pole is not the best method of eliminating power line noise. That's my statement. That's how I feel. When you tighten all the hardware on the pole, keep in mind that every pole on the system is loose. Poles aren't loose. The hardware on a pole isn't loose because of a lack of maintenance. The pole is loose. All the hardware is loose on the pole because of the wood shrinkage. The wood shrinks, the hardware can't absorb the shrinkage, and all the hardware becomes loose. Every pole, if you see a pole with loose hardware, go to the next pole. It'll be loose too. They're all loose. That's the way it is. In windy areas, the poles that break first are the ones that are the tightest. They don't give. They don't flop around in the wind. They don't give at all. So when one moves, the other one doesn't move, snap, it breaks it off. The loose hardware helps to absorb things that hit the line in windy conditions and so forth. Tightening all the hardware, it's a lot better practice to find the exact point of the spark and repair that. Chances are, and many times I send a lineman up a pole. And the first thing he does, he wants to tighten everything on the pole. So to satisfy him, I say, okay, tighten everything on the pole. He tightens everything on the pole and he didn't hit the noise, because the things that they believe are the causes of the noise are the things I've mentioned previously and not what the cause is. So therefore, what typically happens is they tighten the hardware on the pole. And as they do that, they shake up the source and the source may stop, but then it comes back a week later. And the explanation for that would be, well, we fixed it the one last week, but now you got another one. And then they try to make it look bad for you because now you've got another noise, and there's no reason for you to look bad. It's not your noise, but at the same time, they didn't fix the right one in the beginning. Therefore, when they stop the noise, it comes back over time. This is very, very common for these things to happen like this. Okay. Sometimes these things are really easy. Sometimes I get hired and I go out and I get there on Sunday and I've got Monday and Tuesday to work on a problem. I get there Sunday and I'm there for about an hour and I find the problem. And that happens frequently. But there are times when I might find the noise to be several miles away. I don't know if you can see. Can you see my mouse moving?
Yes.
Okay.
Yes.
Good. Sometimes that works. Sometimes it doesn't. This is where the complainant was. The complainant was here, and the RFI source is way over here. This is a pretty good distance. When this noise came on at this source, it blanketed a radius about 4 times from here to here. The noise was everywhere. These noises can be very difficult to find, but with the right methodology and the right equipment, it can make it a whole lot easier. Doing things haphazardly, relying on luck, doesn't make you very successful. It's very, very difficult to find some of these things. Now, what causes these things? Anything on this pole, anything that's metal to metal, any 2 conductive pieces of material that are close together on this structure can be the cause of noise. You've got the power line. In this case, it's 7,200 phase to ground. So between 2 phases, they would refer to this as a 14 kV feeder. Okay. And that's measuring the voltage from phase to phase. At this the primary conductors here, the primary conductor being, see if I can get his mouse to work, being here and here and here. Those are the 3 primary conductors or primary phases. The electromagnetic field around this radiates out, and about every 3 feet or so, it cuts the voltage. The radiation level is cut in half, but it gets induced as it crosses over all the hardware on this pole. That voltage gets induced into this conductive hardware. When it gets induced into it, it energizes this. So every half cycle, the energy starts over again, and you've got energy. So if you've got a bad connection here between any 2 pieces of this hardware, that energy energizes one piece of hardware a little more than the other, such as right here. I'll zoom in a little bit. Here we've got a bolt coming through the pole that's holding this bracket, another one at the top, coming through, holding on to that. And right here, the energy is energizing this washer and energizing that bolt. The washer will be energized to one potential, the bolt the other. They're separated by corrosion, the corrosion that's formed between them. So if they had a good connection, they'd both be the same voltage and the same potential, and there would be no sparking. But because they're separated, there's a difference of potential. And when that gap created by that corrosion breaks down, it discharges. So every half cycle, you get a discharge. The smaller the gap, the more discharges you get per half cycle. The larger the gap, the fewer discharges you get per half cycle. When that occurs, that arcing and sparking, that sparking creates RF. That RF radiates out away from that spot, and it gets connected or gets induced into everything on the structure that's close to it. The closer it is to it, the higher the level of RF induction, and it radiates from that, using that as an antenna. Well, if that radiates over and gets into the ground wire on this pole, and that ground wire becomes an antenna for the noise. As it conducts along that ground wire and goes down and connects to the neutral on the pole, now it has the neutral to use as an antenna, and it radiates down, and at every pole, it hits another house drop and goes into the house on that neutral, and it just continues on and on. This can get pretty nasty. In this particular situation here, this isn't the noise source. The noise source is actually this staple right here. That staple being loose, the ground wire, ground potential, the staple getting the induced voltage from the primary is energizing this staple. That staple is trying to equalize its potential to the ground, and it keeps sparking. Every half cycle, you get a spark in this joint. Now, this pole, if I were to send a lineman up this pole to find this problem, he would certainly tighten the visually obvious loose things on the pole, and he might even bang those staples in. He might get lucky and it short the staple and it won't arc anymore. He might be lucky and tighten that bolt up and it move things enough or shake the pole up enough so it doesn't spark anymore. If that's the case, everybody's real lucky. But in my luck, they seem to come back. I have to rely more on knowing what I'm doing than luck as it has it. Okay. So, moving right now, keep in mind that this pole, that bolt, notice that bottom bolt is really just as loose as the top one. Okay, the top is tight over here and it's tight out here on the outside of this because the weight of this is pulling down. So it's keeping the top bolt. There's no slack in that. And the bottom, it's pushing into the pole. So over here, you got slack. And that washer is typically an obvious noise source, or could be an obvious noise source. Okay, so these loose hardware is created by this pole shrinking up. It's kind of like the deck on your house. You build a deck on your house out of wood, and if you want the gap between the boards to be a ½ inch, you don't put the boards a ½ inch apart because they'll end up being 1 inch apart. So you butt the boards together, and every time the wood shrinks up, and now you have exactly what you want. Okay, these wood poles shrink up, and the steel hardware doesn't absorb the shrinkage, and then it starts this whole process. Thank goodness for that. It's job security. Okay, this is another common scenario. This was I want to say it was Wisconsin where I was. I'm pretty sure it was Wisconsin, but anyway, I get the call from the guy. They built this the circuit on the left here. this circuit, 138 kV. They built this circuit, and immediately when they energized it, they got noise. And there's a ham to the left, and I don't remember his call. He started complaining right away. It was wiping him out. So I get hired after several months of them getting outages, trying to find the noise. Everything pointed to this pole. They kept rebuilding. They kept working this pole over. They dismantled it, put it back together. And as soon as they energized it, there would be noise on the structure. And the ham was complaining. They would come out, they drive around, and everything pointed back to this structure. So I get there on Sunday night. It's almost dark, and I pull up, and I'm sitting right where I'm at when I took this picture, and I'm looking at it. It's not uncommon for me to pull up in an area like this where there's a suspected noise source, and I sit there and I look at it for a long time and just analyze the whole picture. And after sitting here looking, I got this crazy idea. Every time they energize this structure, the noise comes on. They de-energize it, the noise goes away. They drive down this road, the noise peaks as they drive through here, and everything points to this pole. So I'm sitting here looking, and I'm sitting here and I'm pointing. I got the noise on my receiver. I haven't pointed any directional antennas, but I'm sitting here and I can hear the noise. It's going pretty good. So I'm looking over and I say, you know, what if the noise isn't here? What if the noise is here or even here? So I get out of my truck and I walk up this road and I walk over by this hill and I take my Yagi and I point right to this pole. It has nothing to do with the physical structure here, but when the power is energized, the electromagnetic field from this is inducing a voltage into the hardware on the streetlight bracket and causing noise. Here's a close-up of that streetlight bracket. And this is your noise source right here. This neutral is bare, and it's laying on this steel streetlight bracket that isn't grounded. The electromagnetic field from this circuit is inducing the voltage into this streetlight bracket and causing it to arc right there. All I had to do was reach up there with a stick and pull this off, and the noise was gone. I had them come out tomorrow, and they replaced the streetlight pole. They replaced the pole, the bracket, and the light with everything new, and everything was good. It wasn't necessary to do that, but this was an old mercury vapor, and they were going to LEDs. So they changed everything out, the fiberglass arm or fiberglass bracket, and got rid of these really secondary looking connections here. But that's all it took. They had worked on this pole many, many times. They worked on this structure many times trying to eliminate the noise. And when I spoke with them, I told them, you've worked over it 3 times. Don't get any more outages. You're just wasting your money. And this is very common. Okay, this is a very good explanation for what happens in the utility industry. You got a piece of trash that's hanging on the line. Okay, it's hanging on the primary. Okay, this is very common. You find back in the day when newspaper boys used to have wire tying, holding their newspapers together, it was very common for them to have wire hanging on the line like this. Right here, I've got, say, 7,000 volts on the line, and I've got very close to 7,000 volts on the wire. If I take that wire off, if the lineman comes out and he sees that, they'll remove it. But what happens if I take that wire and hang it down on the neutral? Okay, hanging on the primary at the top, it might have a difference of 100 volts or something. Okay, if I hang it down on the neutral, then the neutral is ground potential. The induced voltage into that hardware from the primary is probably several hundred volts and makes a really nasty noise, much worse than it would be on the primary. Not to mention the fact that that neutral is what goes into your house and is also connected to the ground in your house, which is what you cover and ground and shield everything in your shack with. So all that noise is radiating from all the things that you're wrapping around and doing to eliminate noise in your equipment. This is a very common scenario. Okay, I want to show you a couple of really common things, very simple things to fix, but they build this in the system. This is a fiberglass arm. It's about 4 feet long. It's got what's called a crow's foot on the end. It's got a lightning arrestor over here. It's got a cutout over here. And then this ground wire comes across the bottom of this fiberglass pole and comes all the way down to this lightning arrestor. And right here, it's touching this steel bracket. It's barely touching it. And you can see, zooming in, you can actually see the arc between these two. And all that needs to be done is just pull this away. There is no tool available in the industry to hold this ground away from this. This is what everyone is doing everywhere, with the exception of a Florida utility. They have in their specs that you cannot tape this ground to this pole to this fiberglass stick within 6 inches of the end of it. So this has to be taped here so the ground can be pulled away as it passes the steel and it won't arc. Really smart idea. This is you guys may be familiar with West Middlesex, Pennsylvania. This is radio station K3RFI. This is a guy that's leaving this pole. There's a guy here and there's a guy wire here that goes to a pole across the street. This is 7,000 volts being induced into this guy. On the next pole, where those guys attach, you got what's called goat heads. This is where the guy attaches to the pole. This was arcing right here because of this rust. The induced voltage into this met this rust and it was arcing right here and wiping out K3RFI. The utility company came out a couple of times and just could not believe that this could possibly hit, so they didn't make repairs. I finally convinced them of doing that. They came out and replaced the whole pole as well as the connections here, and that took care of K3RFI's RFI problems at that time. Okay, I go to work for a utility. This is Tennessee, and I'm catching a whole lot of flack from the guys and the crews because I tell them probably what we're going to find most of that day is staples. They had no way of believing that a staple could cause all this noise. This staple was making noise after I banged it into the pole. As you can see, it's pretty tight right here at the pole, and it continued to make noise. So after banging it into the pole and it continued to make noise, I decided to pull the staple out and the noise went away. Well, they still weren't convinced. So the next pole we went to, the guy, it was, of course, one of the younger guys there, and he just had a whole lot of things to talk about. And he just could not believe the staple thing. So the next pole we went to, we found a staple, and I told him to take a voltmeter up and measure the voltage on the staple. So here he is. He's got a probe on the ground, and the other probe is on the staple that I told him was making noise. He's got 139.8 volts on this staple. So there's a 139 volt arc right there on that staple. That's a pretty nasty arc going on there. He still wasn't convinced. We went to the next one. Here, he had to scratch away a place to put the probe on the ground, and this staple had 267 volts induced into it. A pretty serious noise source. These are the things that they don't find unless you tell them that this can happen. These are not the things that they would normally go looking for without being trained to do that. Okay, moving along here. RFI caused by AC sparking sources. There's a lot in that statement. This is using signature analysis. This is a very proficient way of locating noise sources, interference sources, I should say. It's kind of like the fingerprint for the noise. Okay. I go into your house. When I get to your home or your station, I go in, I connect my receiver to your antenna. This is something I do every time I come. If I'm out there for 2 hours looking around, I do it again. If it takes me all day to look around, I keep coming back and hooking up to your antenna to see if this pattern changed. Okay. This stuff all looks the same, right? It's a bunch of lines. What can I get out of that? Well, here's what we got. We got a group of noise. I've got a 2-channel scope here. I've got the one channel plugged into an outlet, so you see the 60 hertz sine wave. And I've got the other one connected to the receiver audio. So this is the noise being produced by the power line. As the sine wave comes up, as the positive half comes up, as the voltage is rising, When the voltage gets high enough for that gap to break down, it discharges. Then it continues to discharge as the voltage is going up. And as the voltage comes down, it gets too low for that arc to jump the gap, and it stops all the way across 0 volts. Then on the negative half, it starts again, and it arcs all the way through. As long as it has enough voltage to jump the gap, it continues. And that repeats every 120 hertz for every cycle. Okay. These spikes represent either the voltage across the gap or the size of the gap. If you change either one of those, this number of spikes will change. The larger the gap, the fewer times it'll jump the gap and spark. And the further away from the power lines, the fewer times, because of the lower voltage, the fewer times it will discharge per half cycle. If you move it closer to the power lines, it'll discharge more times because the voltage is higher. Okay. Now, that's good. So if I count here, I got 2, 4, 6, 8, 10. I got 10 spikes on this positive half, 10 spikes. So if I leave the house, if I leave your house and go looking for noise, if I see anything that's not 10 spikes, I ignore it. Okay. Now, what happens if I see one with 10 spikes? Well, I can't assume that it's yours because there could be 2 noises out there with 10 spikes. So I'm going to look at the top of this surface. Okay. The top of these spikes, the pattern here is produced by the surface of the gap that spark is jumping. So if it's a perfectly clean gap, stainless steel, no corrosion, these lines would all be exactly the same size. But what's happening here is every half cycle, that spark is jumping around that corrosion. So it makes a particular pattern, kind of like a snowflake. There's no 2 exactly alike. Okay. This is the signature. The closer you get to the source, the higher the level, the taller these spikes will become. Okay, so you can use this as your signal level meter and not have to look at the S meter when you're out looking for noise. If I'm out there for 15 minutes and I don't see this, I go back to the house, I hook up to the antenna and make sure this didn't change, because as the pole dries or as the pole gets damp, the size of that gap can change, and so can this noise pattern. Okay, remember, this is what we started with. This is on your receiver. We want to find that noise. So if I leave your house and I see this, what am I going to do? I'm going to ignore it because that is not your noise pattern. Everything that makes this pattern different or make this look weird. People call me all the time and say, man, I got this really strange pattern. I've never seen it before. How am I going to find it? Well, those are the easy ones to find. The stranger it is, the easier it is to find because it doesn't look like everything else out there. So that makes it even easier. So if I see this and I'm looking for your noise, I will ignore it. It's not yours. I'll pay no attention to it. I go a little further and I see this. This doesn't at all look like your noise. Again, I ignore it. I go further. Oh, now this is a power line noise. The other 2 weren't. This is a power line noise, but nowhere near like your power line noise. So again, I will ignore it. Here we are again. Here we've got 2 different noise sources. We've got a 3 spike noise. And if you look right here, you can see it's a little thicker. That's another single spike noise right on top of it. Okay, so there's 2 noises here. Neither are yours. So again, I would ignore it. Okay, now what do I got? Bingo. Now I've got your noise. I found it. Because of this signature analysis, I can tell that this is yours, and I can save this on my receiver. I can actually record a 20-second video of this active noise, or I can save the trace and refer back to it later, utilizing the Radar Engineers Model 243 receiver. Okay, this is the equipment that your power company should have. If your club has it, that's wonderful. Some of these things can get very pricey, and the substitutes for some of these things really aren't worth having, and they actually mislead you. Okay. Radar Engineers are the only company that makes a receiver that's worth having for this job. The 243 is the newest one. The last one before that was 242. Then they had a 241 and a 240. Both of these are obsolete. They don't repair them anymore. The 243 is out, and that's about $7,000. But man, is that thing sweet. If you want a receiver for your club, I would highly recommend that you keep hitting eBay for a RE model 242 or 240. They're out there. Every time I see one, I buy it and usually donate it to a club or give it to somebody local here. Okay, next, the hot stick line sniffer. This enables your power company to find out exactly what it is on a structure that's causing noise. They're right down to the point where you could touch it with a pencil and stop it. This is infallible. It works 100% of the time. Next item, I don't call this a necessity, but it is an enhancement in the process. It's a parabolic dish. It's an ultrasonic locator called the Model 250 or the 251. The 251 is newer. It has a little more sensitivity and has some other filtering features that help keep the ultrasound noise out of the receiver while you're using it on power lines. Very useful tool. This thing, I'm probably about 95% with this. 95% of the time I can detect what it is and tell you exactly where it is. Okay, antennas. Antennas are extremely important. I use a 75, 80 meter vertical on my truck, and I use a Yagi. I think there's a picture coming up of it so you can see it. I utilize this VHF. It's 143 meg antenna I had designed for me, but it's readily available to anyone that wants to buy it from the company that makes it. This is it here. It's called the Telonix H antenna. 143 meg. It's the white tipped antenna. If you want one of these, it's really good, and it is fabulous for 2 meter fox hunts. This thing is extremely sharp. All these are rubber duckies. They're all the same. It doesn't matter where you put them. This thing folds down, or you can angle it up at an angle. The cable comes out of the driven element here, the director or driven element here, and this is a reflector. The elements are all the same. This thing is extremely sharp. It was originally designed for hunting, for locating your hunting dog. I asked them to redesign the antenna for me at 143 meg, and they did that, and they sell a lot of them. A lot of power companies are using this antenna. Here, I've got it mounted through the roof of my truck, kind of like this scenario. This is a convertible type of thing. I put this in a case and I ship it around the country when I travel. So I have the use of a directional antenna from inside the vehicle. This is a training van where I'm training a whole van load of people. And this is my older antenna that I no longer use. This was a Ghostbuster 3619 TV antenna. And I don't use that since getting the 143 meg antenna designed. Okay, locating the sources, the complaint sources, not just any noise. So I start at your house. I go in, I look at your noise. I see your noise. You're on 6 meters. You got noise. You're on AM. What I want to do is I want to hook my receiver to the same place this is. So we unhook the antenna from this, hook it into mine, and I record your noise at 6 meters. Then when I go out and I get in my truck, and I'm going to use 143 meg because I'm using 143 antenna, or if I'm using 80 meters, then I'll be connected at 3 meg and using that with the 3 meg antenna. One thing I wanted to make note of is the reason why it's important to connect the antenna. These noises radiate in wavelengths of whatever frequency you're listening to. So if you change the frequency, it changes the wavelength that it's using to arrive at your antenna, which means that you could have 2 antennas or 2 towers in your property. One could both could have identical antennas. One get the noise very strong and one not get it at all, because it arrives at that antenna at a null and arrives at the other antenna at the peak. That's why it's important to make the connection in your home, because what's heard out in front of your house may not be detectable on that frequency at that place. Okay. So I go into your house. If I can't have access to your house, this is in Florida. This is, I don't remember where this is, somewhere from Bradenton, Florida. And this is one of the FPL guys. This guy, the ham that lived here, called me and said he couldn't be there. I said, if you put your antenna lead out the window, we'll come anyway. If you put your rotor out the window, I'll find noise in all directions. So his noise was to the north. We hooked up, we found the noise to the north, came back, swung around to the southeast and found that noise, and another one to the southwest. And we fixed all his noises, and it was done by the time he got home. And we never saw the guy all day, but fixed all of his noise. Things worked out really good. Okay. Make note, I'm getting old, I got to remember. Remember, I started this search, I think I was at 3.5 meg. I'm at 7.5 meg and I have the same exact pattern. This is still your noise at 7.5 meg. It's important to note that sparking noises are very broad. It doesn't matter what frequency, you'll get the same pattern. I can sit here and dial this frequency all the way down to 1 meg and this pattern won't change. It might get taller and weaker, but the number of spikes does not change with the frequency and the sound doesn't change. That's an extremely important clue. With power line noise, if you're monitoring it and you change the frequency, as you change the frequency, the sound won't change. If the sound changes, it's not a sparking source. And that's a very important clue that utilities use and I use. If I tell you to play the noise or I ask you what happens when you change the frequency and you tell me where, it changes as I change frequency, I say, well, it's not a sparking source. That's a very major clue as to whether it's power line or not. However, there are broadbanded noises that aren't power line that can still create the same type of noise or the same type of pattern, not a visual pattern, but the pattern of not changing as you change frequencies. Okay, once I do that from inside, what I'm going to do is I'm going to connect your antenna. If you've got a rotatable beam, I'm going to rotate the beam and I'm going to find the direction that the strongest noise source is in. Okay, if you're working to the northeast and here I am, I'm pointing to the northeast, I'm going to draw a line on a map or use Google Earth. I'm going to draw a line from your shack in the direction the noise is coming from. Then I'm going to go out and I'm going to look up at your antenna and decide which direction your antenna is pointed in. Okay. Once I decide what direction it's pointing in, I'm going to verify this. And I'm going to say, okay, I'm going to leave your house and I'm going to go here. I'm going to come around the corner, go here, and I'm going to come up the road. Everywhere this line crosses a power line is where I'm going to go and look for that noise radiating. And then I'll follow it from that point to the source. Then I'll come back and do it again and find the next strongest noise in a different direction and do the same thing again, again, and again, and again, until they're all fixed. This is Lafayette, Louisiana. I guess you can see that call sign there. Okay, verifying the direction of the antenna physically, visually, looking up and looking at it is very important. For your guy, for your utility, and for you, because I have gone, where'd I go? I went to Colorado. This company had been working for this ham for like 4 or 5 years trying to find his noise, and he had been sending them in the wrong direction. His antenna was 180 degrees out, and they had been looking in the wrong direction for years. And I walked out and looked up and saw it was pointed in the wrong direction, and it was 2 blocks from his house. This is the kind of things that I run into all the time. Once you're out, you locate the structure, then you're going to get out on foot and you're going to walk around the pole across the street, equal distances from 2 poles. So you want the pole to the left and the pole to the right, and you're going to decrease your gain until you know it's one of those 2. So if you're pointing your antenna to the pole to the right, and then you swing to the left and the noise comes up, you go to the left, go beyond that pole, point back to the pole that you were last at, pointing to the pole to the right, you turn your gain down to make the noise very weak, then you rotate your antenna to the left to the next pole. If the noise is that way, it'll be stronger. If it's at the structure that you started at, it'll go away when you point to the other pole. It really is that simple. I make it sound simple, don't I? This is very important. I make a lot of money off of those aftermarket MFJ dishes. And I want to explain to you why that is. This is a Radar Engineers Model 250 parabolic dish, and it works very, very good. It's very accurate. I'm really good at using it as anybody would if they used it as often as I did. The problem with the MFJ is it isn't very sensitive. And so what it does is it detects things that are very obvious and very easy to see, but the things that are hidden behind something or inside of something, it doesn't detect. So most of what you hear with that are corona sources, things that are emitting corona. And it's extremely common for that to happen. What happens is, wrong way. These brown pin type insulators they emit corona in this area all the way around them, right in the center of the insulator. The corona that discharges off of these at 7 kV and higher. I've never gotten it on 4 kV, but from the ground, if you point up at one of these brown pin type insulators and you think you found your noise, I would venture to say that's probably not it. In Lubbock, Texas, I had a case where Lubbock Power and Light and Excel Energy were trying to find a noise. The FCC came out and gave them a list of 42 noises that had to be fixed to rectify this interference complaint. Lubbock Power and Light called me and asked me what to do. And I said, well, you can fix the 42. There's no guarantee they're going to make any difference to his noise level, or you can hire me and I'll come down and find him. They hired me. I went down. The first noise I found was 2 miles away. It was a staple below the secondary zone, 2 miles away, 100% verified. All the noise stopped when I fixed that, or all the noise from that source stopped on everybody's radios, including the hams, when we put our finger on that staple. I went through, I found 43 noise sources interfering, contributing to the interference level at this ham shack. After fixing the 43, it took me 3 days to find all of them. His noise level was about 1, down to an S1. I even went to 2 local broadcast stations and had them work on their transmitters and line their transmitter up because it was splattering. And it rectified weaker noises that were affecting his noise floor. But we cleared all this up. I called the FCC on Thursday morning and I told them, I said, well, I'm here. I said, the noise is all cleared up. He has 0 electrical power line noise, no noise whatsoever. He's down to an S1 and the customer is very happy. And after doing that, the guy says, really? He says, that's awesome. You found more than I did. I said, yeah, I sure did. He said, well, how many of them of mine? How many of them were mine? I said, none. He said, how many of them did you have to fix before you figured that out? I said, none. I didn't fix any of them. I guess he was a little hesitant because, you know, they think you should do what they tell them to do. And I certainly disagree. I'm there to fix interference, not noise. And I didn't fix one of the locations that they would have fixed had they not hired me. That's so typical of a scenario that there's so much work getting done out there that doesn't need to be done. It's very common for me to come behind a company that spent over $500,000 to rectify one complaint. And I find it in a couple of minutes. And sometimes it's not even the power company that's causing the issue. Okay, power line noise characteristics. Of course, it's sensitive to weather. Damp weather, windy weather, high humidity days typically shorts the noises out. Dry days typically makes it more active. Broad frequency range, that's very important. You got noise on the AM broadcast band radio in your kitchen and it affects 530 or 820 or 830, whatever it affects, but doesn't affect the next station, it isn't power line. Okay. The audio and scope patterns don't change when you change frequency if it's a sparking source. It'll get weaker as you go beyond the resonance of the antenna and die off as any signal would, but it doesn't change with the frequency. Okay, no presentation would be worthy without a quick talk about safety. This was my assistant back in 1980. We were walking through the streets of College Park, Maryland, banging on poles to try to disturb a noise. And as we banged on the poles, we would write down the one that disturbed the noise and then look at it further. We got to this point and there was a building behind where I'm standing here taking the picture of Tim. And people were looking out the window, watching us do this, probably wondering what the heck we're doing. And I told Tim, I said, Tim, we ought to go down, get the car, put our hard hats on and look a little more safe and professional. So we did that. Tim had the receiver in his hand. I took the sledgehammer and I hit this pole. When I hit this pole, a lag, one of the telephone company lag bolts fell off the pole and hit me on the head, hit me on the hard hat. I may not have been standing in that same position if I hadn't moved to go get the hard hats and so forth. Who knows? Maybe it would have hit me in the back and the shoulder. But point being, you've got several thousand volts overhead and there's an arc up there. It doesn't take a genius to figure out you shouldn't be standing under it, beating on it with a sledgehammer. So don't do that. Don't hit the poles. Don't pull the guy wires. Very dangerous. This is the result of many years of a particular ham. I certainly wouldn't mention any calls or names, but he beat on this pole for 10 years. All the neighbors told me all about it. He'd been beating on this pole for 10 years. The bottom of this pole looked like an advertisement for a Slim Fast commercial. Looked like a really nice figure at the bottom because he had beaten that pole small. Well, lightning had struck this and burned it. When it burned it, the tie wire was holding the line together. This only went one span to the transformer that feeds his house. He knew I was coming that morning. The company had hired me to come out and find the problem. I called and told him I'd be there at 7 a.m. When I got there at 6:45, he was standing there with a sledgehammer in his hand and this line was on the ground burning. Very, very dangerous. The kids had just gotten on a bus, and I guess he waited for the kids to get on the bus before he hit the pole. Very dangerous situation. So please don't do that. And that concludes my presentation. I want everybody to know, remind everybody that February 11th, we'll be back and I'll do an enhancement about this with a little more instructional slides on what to do, how to do it, and how to locate power line noise. With that, I'll pass it over to whoever's taking over from me.
Mike, that's great. Do we have questions for Mike? Like, how big of a sledgehammer should we be buying?
A big plastic one.
Hey, Mike, this is Walt, AJ6T in Tennessee. That was very interesting. Could you say a word about chasing down sources of noise in your own shack, though? Power supply noise and things that are right next to you, biting you in the ass?
I'll make it really easy for you. If you go to rfiservices.com, there's an information sheet on the webpage that'll tell you how to find it in your shack. And there's also an information sheet that'll tell you how to find which home it's in if it's in a neighbor's home.
All right, very good. I'll do that. Thanks.
Yeah, that was it. That was one of those slides I had to take out. I had about 6 slides on that subject, but it would have, as you can see, I'm running pretty tight here for time.
What was the source of the first noise you mentioned that covered such a huge area?
That was a 230 kV a potential transformer at a substation. I could actually hear it. I could disconnect my antenna when I got there, could hear it buzzing. I got the circuit out. I went up in a bucket, scraped it clean, put some conductive grease on it, put it back together, and it's still that way today and not making noise.
Do you see many the higher voltage, like 115 kV and above issues, or is it mostly the distribution?
It's more so distribution, and that's primarily because of the wood structures. When I'm in an area with a lot of transmission, that's mounted on wood structures, there's always noise on those as well.
Okay, thank you.
You're welcome.
Yeah, how much trouble do you find with the arresters?
Well, I was going to get really deep into that on the 11th program with pictures of the components. That is probably one of the most common sources now. And it's a very, very easy thing to rectify and eliminate. But it's very hard to get the point across, especially when the manufacturer is telling you there's a different reason why they're doing it. But I find a lot of lightning arresters causing problems. These arresters are not bad. They'll make noise, but they still work. They'll make noise for years. It's not because they've been activated. It's because they've got moisture. Moisture has gotten in them and they start to spark internally, but they still work.
Yeah, I understand that. I appreciate your comments on that. I retired 14 years ago after 40 years with a power company, and that's consistent.
Yeah, they've been doing that for a long time.
Mike, they replaced a power line, very high voltage one. I assume at least 72K you got. It comes up to the corner of my lot and then comes from the west, goes north. But I noticed they used wood poles in this case. You might comment about the new metal ones too, a different subject. But I noticed on these poles that the entire bottom, maybe 15, 20 feet up, is all a wire cage all the way around the pole, not just a wire going down it.
Yeah, just around the bottom.
Yeah, well, it's about 15, 20 feet up that it goes. Yeah.
Oh, it goes that high up?
Yeah.
It goes out. What state are you in?
Wisconsin.
Wisconsin. Honestly, I'm not familiar with it being down there going all the way up. One of the major reasons for using that is to keep the critters from digging into the pole. Woodpeckers, for one, it's very common to have that at the top of the poles for woodpeckers, because they will annihilate a pole. Down the bottom, I'm not familiar. I don't think I'm familiar with it being at the bottom half.
Okay, I thought maybe it had something to do with trying to improve the grounds.
No, I mean, the ground's what it is. There's several different methods to use on the ground. Sometimes it's a butt wrap, where they actually wrap the ground wire around the base of the pole, and then they put the pole in the ground. Sometimes the ground is put in the hole, and then the pole's put in. Sometimes it's pre-stapled to the pole. Sometimes there's 2 or 3 ground rods coming away from the pole, in real sandy areas to give it a better ground potential. Sometimes there are plates that are mounted under the pole and the ground is run to that. There's all kinds of different methods they use.
Have you had any occasion to deal with noise on the new, whatever, the copper rust metal poles?
Copper rust metal poles?
Well,
Yeah,
they-
it's
they
kind of
use some kind
crazy, isn't it?
strange copper coating on it.
Yeah, well, it looks like copper. It's rust. The idea is that if they don't clean this rust off, it won't rust any further. And that's what the power company here where I live tells me. I see these poles going up that are all rusty. And I said, what the hell's wrong with this? You're putting rusty poles in, and they said, well, it won't rust any more than what it is. And it's been probably 15 years since they put them in, and they haven't. So I don't know how that works, but I haven't found that to be a noise issue or any more of a noise issue. You had mentioned something about steel poles. When there is a noise at a pole or close to a pole or on a circuit that's attached to a pole, they radiate the noise like a vertical antenna. The noise is radiant, very strong. Imagine having a thin wire for an antenna or a thick wire for an antenna. The difference. The pole being huge seems to do a much better job than the very thin, than the thin ground wire that would be coming down a wood pole.
Mike, any hints as to, someone who is experiencing noise, how they should approach or communicate that information to the power company to get kind of the best response?
Yeah, it's regional. I hate to say that, but it is, because what you say to one power company may mean something totally different to the other. I give presentations to the call centers at power companies, and I give them a list of words. I say, if somebody calls you and uses one of these words in their description of the noise, because everybody describes things differently and people's interpretations are different. I say, if they say one of these words in their description of the noise or description of the problem, send it to this group. And that works out really well. And then they really learn how many noise problems they have out there, because they've been going to the wrong place for years. But when you call in a noise, number one, you're a licensed radio station. That's important. If you want to promote being a ham, you can. I don't think there's an advantage to that. I think it's a disadvantage. If you tell them you're a licensed radio station and the FCC says this, the FCC says you must stop any interference that's any signal that's interfering with a licensed radio station, and that's good enough. That'll get the point across. If you tell them that there's an arcing on the pole, then they're going to send a man out to the pole at the address you give them, and he's going to check the connections on that pole, and that'll be the end of it. He's going to turn it back in and say, I found no problems with the neutral. And it's not going to be if it were the neutral, your lights would be getting brighter and dimmer and all that stuff. That has nothing to do with it. It's very difficult to find somebody. I mean, I could probably tell you most of the power companies that have someone that's good at finding noise. I've worked for, well, obviously not all of them, but thousands of them. And not everybody has somebody that does this, you know, and you also have to consider that the guy that's coming out might do this once a year and may have never done it before because they just don't have enough to have someone that specializes in this. And I get that. But there is a recommended practice, a standard that's coming out. It's available right now through the IEEE. We had a committee that met for 5 years of like 16 people, me, several utility, a few utility interference investigators. Riley Hollingsworth from the FCC was on the committee. The ARRL actually conducted the committee. And we just completed the book. It is available, I think, today or yesterday, I think was the first day it was actually available in the IEEE. It's the P1897 recommended practice. And it is available. It isn't cheap. I think it's like $100. But it is a Bible. It is very, very thorough. There is one thing that I disagree in that whole book, and the committee actually wrote this book. We wrote this book. There's a blurb, there's a section in there about TV interference that is absolutely false. And we made some concessions, and there were, I guess we settled our differences in this somewhat, but the cause of interference to TV, the pixelating of your TV picture has nothing to do with power line noise. And there were people that thought that it should, but everything in this book is gospel. It's true, tried and tested. There's many illustrations, procedures, and I think it will be the recommended practice for utilities everywhere. As age goes on, there will be more and more utilities that are utilizing the steps that we have in this book, and it'll make things much better for everybody.
Any other questions for Mike?
Yeah, hi, Mike. This is Fred, K9 Victor Victor. I live in a very highly corrosive environment in the island of St. Croix. So we have spray, saltwater spray and all that. Any special hints we might be inclined to undertake when we're looking for sources in that kind of environment?
Well, you're going to find a lot of noise at insulators, kind of like that brown one I was talking about. And actually, it's audible. You can hear it when you walk past a pole typically. But that isn't going to be your noise. There is no better method, in my opinion, there's no better method of locating noise than using the signature method with an oscilloscope. It's infallible. It can't fail. So by utilizing that practice, your noise, when it's recorded at the home, that noise will be what you're looking for in the field. If you don't see that pattern, that's not yours. Anything you hear on a pole, ignore it. If it isn't your noise, ignore it. The saltwater type of noises, the salty air noises at insulators are not sparking. It's not sparking. And the corrosion issues and joints is certainly an issue for you. But again, stick with that pattern. If it isn't your pattern, it's not your noise, and that will eliminate 99% of what you're out there looking at.
Thank you.
You're welcome. Well, guys, it's been a pleasure talking with everybody. I appreciate your time. I appreciate everybody coming on here, and I hope everybody joins us on February 11th for part 2.
That's great. Everyone have a good evening, and now we can go off and listen to another debate. So good night to everyone.